And again, let's see what happens if I give it the exact number. You guess it. And again, it goes down, finds case 7, sees the break, and exits the switch statement. So we're fine there. Now, there are other situations. What if I type in something that's not valid, not 1 through 10? What if I type in 100? It doesn't match any of my cases. So that brings us to one more part of a basic switch statement, and that is the default statement. If none of the cases match, you can include code under default, and the default statement would execute. And I could also test if it were a character, not a number. I could do something along those lines, but I'm testing for that up here. We talked about trying and catching exceptions, and I'm catching a number format exception. So what I could do down here is simply say, well, I could just say 1 through 10, please, and I'll just move this to the next line so you can see it easier. Alright, so now with that default statement in there, if I don't match any of the cases, let's say I feed it 100 or the number 500, that'll tell me the number is out of range. 1 through 10, please. So, two different types of structures. This sort of works like the last else in a chain of if and else if. The way looking at the default. And a switch statement, yeah, I can't do all of the things I can do with an if, as far as comparisons and more complex decisions and evaluations or function calls. However, it is a very short, concise, efficient decision mechanism that I can use to incorporate logic into my code. Remember, a switch statement begins with the keyword switch. The code you want to execute is enclosed in curly braces. Within parentheses, you're going to place a condition, and this will be a simple variable that you will test. After switching on the simple variable, a case will be met. Case 1 would cause the code there to execute until the break. Case 2 will cause the code there to execute until the break. If neither case 1 nor 2 were met, the default would execute. If I were to switch on an integer, then I would begin each case with the keyword case, follow it with an integer, then a colon, and then the keyword break, and terminate it with a semicolon. Were the case not matched, I would add other cases, and were they not matched, then eventually the default statement would be reached. Were I to switch on a simple single character, I'd start with the keyword case, and then the single character. I'd enclose it in single quotes, not double, use a colon, the keyword break, and then a semicolon. If the first case were not met, program flow would continue to the second case, or to the default statement, until break is reached. Whatever data type you're switching on, remember, if none of the cases are matched, then the default statement would be executed. If I leave a break off of a case, then it will continue on to the next case and execute the code there until a break is encountered. Sometimes this is by design, and it's exactly what you want. In other words, if case 1 is met, I want that task to execute, but I also want it to go down to case 2 and execute that task, and then perhaps to the default statement. However, sometimes it's inadvertent or accidental. You simply forget and leave the break off. In this case, you'll wonder why certain cases are executing when they shouldn't be, or when their conditions are not being met. I can't switch on complex data types. In other words, if I were to try to switch on an entire string, I couldn't do that. Syntactically, that would not compile. It would be wrong. I can, however, switch on a simple character. So if I wanted to switch on a string, I could use the function char@ on the string to get a single character and switch on that. That would be acceptable. Remember for a character that your cases must be in single quotes. I can't do complex comparisons in a switch statement. In other words, I couldn't switch on an integer called age and then make my cases whether age was greater than 50 or greater than 51. I can switch on simple values, so I could build my case on simply if age is 50 or age is 51. With if-else statements, I may use logical operators like and, or, and not. This is not the case with switch statements. However, when there are small, concise, and quick decisions that need to be made, switch statements can be a very efficient decision structure.